This is question 11. For this question, you're given two functions, f and g. You're also given the domain for each function. Parts A and B only refers to f of x, and then you're given the graph of both functions. We can see that x equals to a and x equals to b are the vertical asymptotes. So this occurs when cos of x is equal to 0. So you can even write down your answer. A is equal to pi by 2. B is equal to 3 pi by 2. Easiest 2 marks on the exam. Part B, differentiate this guy. This one's not hard. We have a quotient of two functions, so we will be using the quotient rule. F prime of x is equal to cos of x times cos to the 4 minus sine of x times the derivative of cos to the 4. So that would be 4 cos cubed times the derivative of cosine of x, which is negative sine of x. Downstairs, that's gonna be the denominator squared, or cos to the 8. I am going to simplify this a bit further. So we should get 4 cosine cubed sine squared of x divided by cos to the 8. I'm going to divide both the top and bottom by cosine cubed because it cannot be 0. The reason I'm doing this is because you're now asked to prove that the derivative is less than 0 on the middle part. So, on the interval AB, which is pi by 2 to 3 pi by 2, cos of x is negative. You can quickly remind yourself of the curve, and we are talking about this portion over here. So if cos of x is less than 0, cos to the 5 is also less than 0. Cos squared plus sine squared upstairs. This is gonna be 1 plus 3 sine squared upstairs, so we know this guy is strictly positive. Therefore, top divided by bottom must be strictly negative, or f prime of x is less than 0, as requested. Part C. We want to verify that f and g intersect at x equals to pi by 4. So, that means that we have to show that f at pi by 4 and g at pi by 4 are equal. F of pi by 4, this is sine of pi by 4 divided by cos to the 4 of pi by 4. So, root 2 by 2 divided by root 2 by 2 to the 4. And you will get 1 divided by root 2 by 2 to the 3. G of pi by 4. This is tan cubed of pi by 4 times secant cubed at pi by 4. Tan cubed at pi by 4, this will be equal to 1. Secant cubed at pi by 4, this is 1 divided by cos of pi by 4 cubed. And you would get the same value. Because they are identical, you can then say f of pi by 4 is equal to g at pi by 4, i.e. they intersect at x equals to pi by 4. Part D. Look at the graph. This is going to be your f. This is going to be your g. You want to show that f of x is greater than g of x on this interval. The easiest way is to consider f minus g. f is sine of x divided by cos to the 4. G is tan cube times secant cube. Not much we can do here unless we manipulate this guy. So we can rewrite this guy as sine of x divided by cos of x times 1 divided by cos cube of x. Noticing that this guy is nothing more than tan of x, and this guy is secant cube. And you will see this result again here. So we can now factorize tan of x and secant cube. We are left with 1 minus tan squared. Okay, what next? On the interval from 0 to pi by 4, we know that tan of x is positive. In fact, we know that tan of x is also less than 1 if you recall the graph of y equals to tan of x. We also know that cos of x is positive on this interval. Therefore, 1 over cos, or secant, is also positive on this interval. So, this term is positive, this term is positive. If tan is less than 1 and greater than 0, that means that tan squared is also between 0 and 1. That means that 1 minus tan squared is also between 0 and 1, aka positive. Now we have a product of 3 positive values. This product must therefore be positive. It's already a lot of writing, eh? Up to this point. Okay. Part E. You're not asked to show this is true. 2 marks, so this shouldn't be that bad. So, f of x is equal to negative f of 2 pi minus x. F of x is sine of x divided by cos to the 4. Just a quick recap. The right-hand side looks more convoluted. Let's do that. Negative f of 2 pi minus x. This is negative of sine of 2 pi minus x divided by cos to the 4 of 2 pi minus x. The period of sine of x and cosine of x is 2 pi. We can simply get rid of this. So we are left with negative sine of minus x divided by cos to the 4 of negative x. Sine of negative x. We can see that sine of negative x is equal to negative sine of x. Cos of negative x is equal to cos of x. So we will get sine of x divided by cos to the 4 of x. In other words, it's f of x. So this is part E. Part F. Using a substitution, show that this integral is true. This looks scary. This is part F. The integral of secant cube tan times tan squared minus 1. Okay. Secant cube times tan x tan squared minus 1. How do we find this integral? You're already given the substitution. If u is equal to secant of x, the u is going to be sec of x dx. Sec x tan x dx. We can split this secant cube into secant squared times secant x tan of x. This is going to be your du. That means we have to convert what's left in terms of powers of secant of x. We know that tan squared plus 1 is equal to secant squared. Therefore, tan squared, that is secant squared minus 1. Now we can carry out the u sub. Wherever you see secant of x, you replace it with u. And you have the integral of u to the 4 minus 2u squared. This is now very straightforward. It's going to be u to the 5 divided by 5 minus 2u cubed divided by 3 plus c. And now you're going to return to center. You start with secant, you end with secant. You start with x, you end with x. You do not end at u. That will cost you a mark. Okay. What is the point of all of the question parts that we have done up to this point? Let's go back to this graph we have here. We are asked to find the total area of the regions. So 1, 2, 3, 4. We also know that this is true. And we know it is symmetrical. What does that mean? That implies that this region over here has the same area as this region over here, has the same area as this region over here, and has the same area at this region over there. You can write out 4 integrals, then show that they are all equal. Or you can state that this is 4 times the area of the region bounded by f and g between 0 and pi by 4. Part G. The required area is 4 times the integral from 0 to pi by 4. F is the one above, G is the one below. F of x, that is tan of x, secant cube of x. G of x, that is tan cube, secant cube. And if you are connecting the dots right now, you can see that this is what we just proved earlier. So all you have to do is using the results that we have established here. This is actually a negative of the answer you have in part F. So we would get minus secant to the 5 x divided by 5 plus 2 secant cubed divided by 3. Plug in the upper bound and the lower bound. So you would get 4 times negative secant of pi by 4. So 1 divided by cos to the 5 of pi by 4. 2 divided by 3 cos cube of pi by 4 plus 1 by 5 minus 2 by 3. Take your time with this. Cos of pi by 4, that's root 2 by 2. Two to the 5, that's 32. Downstairs, we have this guy. 2 to the 3, that's 8. Downstairs, we have 2 by 2, 2 root 2. A bit further, we would get 4 root 2 divided by 5. We get 4 root 2 divided by 3, and 7 by 15 over here. Put it over the same denominator, we would get 20 root 2 minus 12 root 2 minus 7. And yes, that is indeed equal to 32 root 2 minus 28 divided by 15, which is our printed answer over here. So this is the end of a very elaborated question on curve sketching. It's not hard, but it's pretty damn long. And I hope you find this a useful exercise that recaps a lot of the stuff that you have seen